Hello, welcome to my math cast. The intended audience is for third graders. The learning objective is to generate simple equivalent fractions by using visual fraction models in the number line. This is created by me, Rebecca Lugo. Let's start off with some vocabulary. We are going to go over what a fraction is, an equivalent fraction, and a number line. A fraction is a number expressed as some number of equal parts of a whole. For example, in fraction a over b, there are a parts that are each the size of 1 over b of the whole amount. For example, in the fraction 3/5, there are 3 parts, each size 1/5 of the whole amount. The fraction 3/5 can be represented by either using a strip diagram or by using a number line. As we see, both representations are split into 5 equal groups, 1, 2, 3, 4, 5, and 3 of them on the strip diagram are shaded in to represent 3/5, and we have a dot on the 3/5 line representing 1, 2, 3/5 on the number line. Equivalent fractions are 2 or more different fractions that represent the same quantity. The first representation is 2/6 and 1/3. In the fraction 2/6, the whole is separated into 6 equal pieces. 2 pieces are shaded to represent 2/6. For 1/3, the whole is separated into 3 equal pieces, and 1 piece is shaded in representing the fraction 1/3. As we can see by the picture, 2/6 and 1/3 are equivalent fractions. The second representation is 1/2, which is a whole separated into 2 equal parts and 1 part is shaded. 2/4, which is 1 whole separated into 4 equal parts and 2 pieces are shaded. And 3/6, where the whole is separated into 6 equal parts and 3 pieces are shaded. We can tell by the picture that these 3 fractions, 1/2, 2/4, and 3/6, are equivalent fractions. A number line is a diagram in which numbers are represented as points on a line. In this number line, we see that it goes from 0 to 9 with intervals of 1/2. So it goes from 0 to 1/2 to 1 to 1 and 1/2 and it continues on. Let's try an example. Write 2 different fractions. For the dot on the number line, we may use halves, thirds, fourths, fifths, sixths, or eighths. We could even use fraction strips if necessary. As we see here, the whole is from 0 to 1. Let's see how many parts make up that whole. 1, 2, 3. So we're going to use thirds for our first fractions. We know that 0 to the first tick mark would be 1 part of the whole, size 1/3. So we know the first tick mark is going to be 1/3. So the second one is going to be 2 parts, each 1/3 of the whole. And then 1 is going to be 3 over 3 because it's a whole. Let's separate the tick marks at the halfway marks. Let's count how many parts make up that whole. 1, 2, 3, 4, 5, 6. So now we know we're going to use some 6. So the first one's going to be 1/6, then 2/6, then 3/6, 4/6, 5/6, and 6/6. And 6/6 equals a whole. Now by looking at the number line, we can see that where the dot is on the number line, 1/3 is equal to 2/6. Let's try another example. In example number 2, Cameron and Terrence plan to run in the city race on Saturday. Cameron has decided that he will divide his race into 3 equal parts and will stop to rest after running 2 of them. Terrence divides his race into 6 equal parts and will stop to rest after running 2 of them. Will the boys rest at the same spot in the race? Why or why not? Let's draw a number line to explain our answer. On our number line, we have labeled 0 and 1. This represents the whole race. We know that Cameron wants to divide his race into 3 equal parts. So let's divide 0 to 1 in 3 equal parts. 1, 2. So now we can see here that by putting those 2 tick marks in, we can see that there is 1, 2, 3 equal parts. So let's put them fractions in. 1/3, 2/3, and 3/3. We know that Cameron wants to rest after 2. So we are going to put our tick mark at 2/3. Terrence wants to break his race up into 6 equal parts and stop resting after 2 of them. So let's break this number line into 6 equal parts. Now we can see here that there are 1, 2, 3, 4, 5, 6 equal parts. Let's put them fractions in to label our number line. 1/6, 2/6, 'Terrence wanted to rest after 2 equal parts of his whole race divided into 6 equal parts. So we know that we can label his resting spot at 2/6. Now we can see that Cameron and Terrence will not rest in the same spot of the race. When Terrence rests, Cameron will only be at 1 out of 3 parts of his race. When Cameron rests, Terrence will be 4 out of 6 parts of his race. Let's try one last example. On the number line, we're going to use a color to divide each of the whole into thirds and label them with their fraction above the line. We'll do this in the color red. We can see here that our number line goes from 0 to 3. We can see that one whole represents 0 to 1, another whole is from 1 to 2, and another whole is from 2 to 3. If we want to split this up into thirds, we're going to have to put 2 tick marks between each of the numbers that are in equal sizes. Now we can label the tick marks with the appropriate fractions. As we can see here, each part is divided into 3 parts, each equal to 1/3 of the whole. Now we are going to use a different color to divide the whole into 6 and then label them with the fractions below the line. We'll use the color blue. We know that if we wanted to separate these into 6 equal parts, we can just put a line between each of the thirds. Now let's label those with the appropriate fractions. As we can see here, the whole is split into 6 equal parts, with each of the parts equaling 1/6 of the whole. Now we're going to write the fractions that name the same place on the number line. We can see here there's many places where the 6 and the thirds meet on the number line. We can see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9 different equivalent fractions. So the first one is 1/3 is equal to 2/6. The next one is 2/3 is equal to 4/6. Next is 3/3 is equal to 6/6. 4/3 is equal to 8/6. 5/3 is equal to 10/6. 6/3 is equal to 12/6. 7/3 is equal to 14/6. 8/3 is equal to 16/6. And finally, 9/3 is equal to 18/6. Wow, that is a lot of equivalent fractions. Thank you for joining me for my Mathcast, and hopefully you've learned something today. The resources I used were from engageny.org, the Math Learning Center apps, and Mathematics for Elementary Teachers, Edition 5. Thank you.